All right, I think we'll get started. Hi, I'm Austin Swanberg. I'm one of the apps engineers at Mechatronic Solutions. I'm going to start off by talking to you guys about Motoman's industrial robots. So over here is the Motoman. Over here we have a TM. Joel, another one of our apps engineers, he's going to be talking about the TM afterwards. So when you're talking about a cobot or a collaborative robot, there's kind of three different instances that you can work with a cobot. The first one is coexistence, where you're working in the same space as a collaborative, but it's not guarded, but you're not actually interacting with the robot in any way, and you're not working on any of the same tasks. You're kind of just in the same occupied space, but doing separate things. Then we get into cooperation, where you and the robot are working in the same space and you might kind of be interacting, but you're still working on separate tasks. So an operator might be doing something at a table over here, the robot's doing its own thing, but you're next to the robot, you still have to interact with it moving. And then the last one is kind of the full collaboration with a cobot. So this is an operator and the robot are working together. They're in the exact same space and they're working on the same task. They're doing the same thing together at the same time. So what makes a collaborative robot collaborative? Kind of how is it different from an industrial robot? One of the big things with a collaborative is you're able to manually move them by actually guiding the robot. So all of the collaborative robots have the ability for you to go and they all have buttons that allow you to actually physically move. I'm in there. One more time. Oh, I can't get it. Sorry, but they allow you to physically guide the robot to the points that you need and move it versus having to jog it with a pen. The next thing that is kind of the main point of a collaborative is that the speed and the actual separation distance that you have to have. So with an industrial robot, you have to have guarding around it. With a collaborative, you can be right next to it. And the biggest thing is that they do basically a speed limit that slows down the robot in order to make it safe for an operator to work right next to it. And then the last thing is power and force limiting. So these robots want to make sure that an operator is always safe, even if they do come in contact with someone. So they can limit the power, limit the torque, and limit the force available on the joints, so that if it does bump into something, it's not going to slam an operator out of the way. It's going to stop, air out, and kind of allow the operator to go unharmed. So Motoman has a variety of different robots. They have industrial and collaborative. Their collaboratives are very fast, so you can run collaborative robots in industrial modes. So for Motoman, their collaboratives have a max speed of 200 millimeters per second when in industrial mode, and they can go up to 1,000 millimeters per second when in collaborative mode, and still allow you to do that force and power monitoring. They all have dual channel torque sensors in each joint, so they're constantly monitoring the torque and being able to adjust, and you can set those limits depending on the actual application. And then all of their motors use Yaskawa's Sigma 7 motors, so they have the torque and the speed to be able to keep up with industrial robots. There are kind of three main operating zones. When you're working with a collaborative, this is typically what we'll see. So the first one is, if no one's in the cell, you want that robot to be able to run as fast as possible, and kind of get as much throughput as you can. So the robots have the option to run in industrial mode, which just allows it to run full speed, kind of no collaborative features. We have the option then to do a reduced speed. So typically this is using area scanners, floor mats, light curtains, stuff like that. But basically, if someone gets within a certain distance of the robot, you're going to slow that robot down to a collaborative speed in order to make it safer for the operator, and if someone does get too close. And then the next one is, when you do pass that warning threshold or that reduced speed threshold and get directly next to the robot, you can go into that PFL mode, that power force limiting mode, which allows you to run at the slower speed. And now you're monitoring all those joints, making sure that if it does collide with anything, it does it in a safe way. Another big thing about collaborative robots is the design themselves. So you'll notice a lot of collaboratives kind of have these offset joints. This allows the robot to have a design that avoids pinch points. So you're not able to kind of get your hand in it, get it caught, and get it kind of have the operator hurt themselves by physically touching the robot while it's moving. It avoids those pinch points. You can also have it where when it's lowering, you're not going to crush your hand. It's going to use that force sensor to safely monitor and make sure that it's not hitting anything on its way to its final point. Motoman's robots meet a variety of safety standards. These are a few of them. They have an IP67 rating, ISO multi-stage requirements for the gripper, and then they're TUV certified. All of Yaskawa's industrial robots come with what is called FSU, or Functional Safety Unit. What this allows us to do is it gives the robot a set of features that allows it to you to safely monitor and kind of set up working zones for the robot. So you're allowed to set up a zone where if an operator is next to the robot, maybe the robot can only work on one side of a cell, or maybe it works on the other. Or if an operator gets close, it slows the speed. All of that is done with FSU, and you can set that up for the application and how you need the robot to perform. Now we'll go into the actual models. So this is an HC10. So this is their smallest robot that Motoman offers. The 10 is the payload. So it's a 10-kilogram robot. It has a max reach of 1300 millimeters. And this is that DTP, that is the direct teach option. So that gives you these buttons on the front that allow you to move the robot and teach directly from the tool flange of the robot. The next robot they offer is an HC20. So again, that 20 is the payload. So it's a 20-kilogram robot. You have a longer reach. Now you have up to 1900 millimeters. This is used for larger palletizing and applications like that. The HC30 is essentially the same robot as the HC20, same form factor and everything. The only difference is they limit the rotation of the joints so that robot can handle now a max payload of 30 kilograms instead of 20. Because they limit that rotation, the reach is slightly less. You'll see on this one, we can go up to 1700 instead of that 1900. But other than that, they're the same robot. You can see on the larger models, the HC20 and the 30, it actually has curved joints compared to this one. And that is to optimize the kinematics of the robot so that it behaves more like an industrial robot and you don't end up with singularities or kind of points that the robot can get into that it might have troubles getting out of. So there's a couple of ways that you can program collaborative robots. The first one is going to be that direct move and direct teaching. So you can move this robot into position. There's a teach button on the arm itself that allows it to teach a point directly where the robot is. So you can drag it to one spot, click a button, move it over to the next, press another button, and now you have a program that allows you to move back and forth between them. There are also two pendant options for the Motoman robots. One is the standard pendant, which is what you'll see on a traditional industrial robot. But the collaboratives also work really well with what is called the smart pendant, which is this right here. And essentially, it just gives you a couple more features compared to the standard pendant. It allows you to easily see what's going on with the robot, adds a little more comments to the actual program. And they also have the option to give you a 3D visualizer. So you can see where the robot is, where those safety zones that you've created are, and just kind of makes it a little more user-friendly. So a couple applications that we're seeing the collaborative robots used are for welding. Collaborative welding is gaining a lot of popularity. You'll have a welding station where an operator can still come and perform the welds that they need to, but for some of the more tedious or repetitive tasks, you can have the robot come in and do that either alongside the welder or just in the same space as the welder. And then probably the most common place that we see these collaborative applications is for palletizing. So here we have a palletizing demo set up where the robot is going to depalletize and palletize in an environment where you don't need guarding, you don't need any kind of sensors. It just does it in a reduced speed with torque monitoring so that an operator can work next to the robot. Motoman robots also have a feature that is called avoidance. So you can see once it picks up this box, I'm able to shove the robot out of the way if an operator needs to get in there, and it'll gently move out and it'll come back to where it was before, resuming the program. So it doesn't stop the program, it doesn't give you an error, it just allows the robot to kind of be pushed out of the way if an operator needs to get in there, and then it resumes it as it was before. The robot also has the option where if you do push too hard, it's going to error out. So if it does hit an operator, it's not going to hurt or shove them. It's just going to hit them and stop. All of those settings, all of those actual torque limits can be set in the robot. That's the HC10. What we do see quite a bit is we will have people that run industrial robots as it kind of in a collaborative mode, similar to what we're doing on that demo. So this is Motoman's industrial robot. This is a GP8, and you can see it's just doing a simple demo, but we have an area scanner and light curtain set up on this. So if I get too close, my area scanner will trip and you'll see it goes into a reduced speed mode. And if I break this light curtain, the robot completely stops. As soon as you release it, it continues with the program. This allows customers to get the max out of their robot by having that industrial speed available all the time and the reliability of the industrial robots while still having a lot of the features of collaborative robots.